Very good morning, class. We have covered our chapter machines. I have done most of the numericals from the chapter, and I told you if you find any doubt, you can reach me out. Okay. Now the next chapter you can see on the board is refraction of light. Light is very strange entity. It behaves like particle as well as a wave. The particle nature of light we will study in the senior class, in the class 12, but here in the class 9th, in fact we are studying the wave nature of light since class 7th, because if you remember there was also the chapter known as reflection of light. In the class 9th we have learned a chapter that was reflection of light, and that is the reflection is a phenomena of light of wave nature. Similarly, there are so many other phenomena of the light, like refraction of light that will be studied in this chapter, polarization of light, diffraction of light, interference of light. Basically, these phenomena we'll study in the senior classes. In class 10th, we'll study about the refraction of light. Okay, so we'll discuss how this phenomena, refraction, is different from the phenomena called reflection of light. What is the reason behind the refraction of light? On what factors this refraction of light depends? So all of these phenomena we'll study in this chapter, and I told you initially that this chapter is very, very important because, as I said, there are some more phenomena of light that we'll study in the class 12th. So basically this is the basic of that advanced phenomena. So to understand the phenomena, the advanced phenomena like diffraction, interference, polarization, you must understand what is refraction. So let's start this chapter, refraction of light. Refraction. First, let's talk about refraction. See, light travels in a medium with a very, very high speed. The maximum speed of light is in vacuum or in air. The speed of light in vacuum is 3 into 10 to the power 8 meter per second. Okay, and also in air it is slightly less than 3 into 10 to the power 8. It is about 2.999 something. So approximately we take it 3, but still it's it's a bit less than the speed in the vacuum. Okay, the speed of light is maximum when it travels in vacuum, but as the light changes its medium, like it start traveling in, let's say, water, okay, or in some different gas, in oil, or in thick glass sheet. So you can see that all of these are basically transparent medium. Light can pass through them, but when light pass through these materials like glass or water or some other transparent materials, the speed of light changes. The speed of light now no longer be the 3 into 10 to the power 8 meter per second, but the value of light decreases. And here the new phenomena arises known as refraction. So what is refraction? Let's talk about it first. Refraction. To understand the refraction, I'll make a diagram known as the ray diagram. Basically, ray diagrams are, we can say, it is very important technique to understand the phenomena of light. In the chapter reflection also we have studied some ray diagrams. If you remember, we made the ray diagrams of the position of the images formed by the concave and convex mirror. That was the ray diagram. Similarly, in the refraction chapter also we have some ray diagram. To understand the ray diagram first in the refraction, there are two types of medium in the nature. First, rare medium, second, denser medium. Now, how can we distinguish between the rare and denser medium? If the light passes through one medium to the second medium and speed of light increases, right? What I'm saying again, suppose here I'm taking two examples. Let's say this is medium 1, this is medium 2. Again I'm taking here again medium 1, medium 2. Light coming from here let's say in medium 1 the speed of light was v1, and in the second medium the speed of light is v2, and when you calculate them v2 was less than v1. So this medium where the speed of light was more will be regarded as rare medium, and where the speed of light decreases will be regarded as denser medium. Similarly, if light passes from again medium 1 to medium 2, again here velocity is v1, here velocity is v2, but now velocity v2 is greater than v1. That means when the light passes from the first medium to the second medium and velocity get increased, that means where the velocity is more, that will be regarded as the rare medium. So now this will be rare medium and this will be denser medium. Okay, so see basically denser and rarer, these are the relative quantities. These are not the absolute quantity. Now what does it mean? See, suppose in the first example, the light was coming from the air and is going into the, let's say, water. Okay, so water is denser than air, but it doesn't mean that water will be regarded as denser quantity all the time, because it is relative. It is denser with respect to air. Okay, now in the second example, let's say glass and water. I've taken the same water which I've taken in this example, but now the light is coming from the glass and going to the water. Now if you compare these two medium, glass and water, now glass will be more denser, right? So in this example, water become rare. Previously, water was denser. So rare medium or denser medium, they depend upon the comparison. They are not the absolute quantities. They depend upon the density of the other medium. So I think now you understood the concept of rare medium and the denser medium. Now let's talk about more about the refraction. Refraction. What is the definition of refraction? The definition is when light passes from one medium to the another medium, it changes its direction. And this phenomena is known as refraction. That means when light passes from one medium to the other medium, they will not go in a straight line. It will bend from its initial path. So this phenomena, the bending of light while the changing the medium of medium, is known as refraction. Now bending, to understand bending, let's see with the help of ray diagram. this line shows the interface between two medium, because obviously when the light traveling from one medium goes to the other medium, there will be some boundary when it changes the medium. So that is known as, let's say, interface. If a straight line and perpendicular to this interface we draw a line which is perpendicular to interface, known as normal. Like this is N and N dash. Right here, this is the medium. I'm taking the above, it is rear medium, and down we are taking denser medium. Okay, first example. Second example, interface, normal. Now here I am taking denser medium and rear medium. Okay, so in the first case, light is coming from the rear medium and going to the denser medium, and in the second case, light is coming from the denser medium and going to the rear medium. Let's see what are the basic difference between these two ray diagrams. When light passes from rear to denser medium, it bends towards the normal. So let's say this is the actual path of the light, right? It is going like this. As it passes through the interface, it will bend toward the normal. See, this light has to go like this, but it will not follow this path. Instead, it bend toward the normal. So what is conclusion? When light passes from rear medium to denser medium, it will bend towards the normal. What will be the different case? When light is passing from the dense medium to the rear medium, so this is light coming from denser medium. It has to go like this, but no, it will not follow this path. Instead, it bend a bit away from the normal. Conclusion: when light passes from dense medium to rare medium, it bends away from the normal. So this is a basic phenomena which happen in the refraction, and this phenomenon is basically reflection. You can see here that light is not following its initial path. It is not going in a straight line. Instead, it's bending. So this bending of light is known as refraction. But the only thing you have to remember that this light bends when it changes the medium. Right? It's not like that the light is going in the water and in water itself bend somewhere else. No, it will only bend when the light changes the medium. Now there are some quantities which is important to understand how this refraction works. But before that, let's understand the reason behind the refraction. When I started this video, I told you that light travels with different speed in different medium. And this is the basic reason behind the refraction. When light changes its medium, the speed of light also gets changed. And due to this, the distance it was covering before in a certain interval of time, now the distance it is covering now, there will be some difference between them. Like here, suppose light is going initially like this and it have to go like this. This is the rear medium this is denser medium. Now when light goes from ray to denser medium, the speed of light decreases and hence it bends, and now you can see that light lags behind from its initial position, and when we lags behind, when we moves with slow speed. Suppose two persons running in the same track, okay, and we can say they are running in the same track. After some time, the speed of one person decreases. So what will happen? The person which is moving with slow speed will lag behind, and same thing is happening with the light. When light changes the medium, the speed of light changes, and due to which the bending will occur. If the light goes into the denser medium, the speed will decreases, and hence the distance covered by the light in a certain interval of time will be less, and hence we can see the bending here. So this is the reason behind the refraction. There are some important quantities in the refraction. To understand the next concepts in refraction and what are the quantities, I have already told you that this is called the interface line, and this is normal, right? And normal is always perpendicular to the interface line. This line, that this point is O and A, so AO is called incident ray. And when it passes, it will bend, so OB is called refracted ray. The angle between the normal and the incident ray, this I. So this angle AOB, AON, angle AON, that is I, is called the angle of incidence. It is very important. Angle of incidence. And the angle between the normal and the reflected ray, that is NOB, this is called the angle of refraction. NOB or BON, you can take BON, that is R, is called angle of refraction. Sometimes a student do a very common mistake. They think the angle of incidence is basically the angle between this incident ray and the interface. No, that will be wrong. The angle is always measured with the normal. Okay, let's quickly take an example. Let's say in an equation, a ray diagram is given like this. It says this is 30 degree, find the angle of incidence. Okay, so student got confused with how they thought the angle is based with the angle of incidence. They thought this is the angle of incidence and they write I equals 30 degree, but no, angle of incidence will be this. This is I. Okay, and let's say this angle is X. So X plus I will be what? It will be equals to 90 degree, because you can see that this is the right angle. Hence I will be 90 minus X, and X is 30 degree. So it will be 60 degree. I equals to 60 degree. So always remember that the angle of incidence or the angle of refraction is always measured with respect to the normal. So today we have learned some basic definition and basic concept regarding the refraction. In the next video, I will do a very important topic which is known as Snell's law and some other topic also. So till then, thank you so much, class.